So for class A, the range of the IP address is 1 to 126. This is the range of the IP address and subnet mask. Subnet mask. Subnet mask is 255.0.0.0 and prefix mask or CIDR notation is /8. Number of the host per subnet. So host per subnet. This is the /8. /8 and number of the host per subnet is to the power 24. It's a very big number that would come 16 lakh something. Class B. Class B, the starting range is 128 to 191. Subnet notation is 255.255.0.0. Prefix mask is /16 and host for subnet is to the power 16. That would come near about 65,000. Class C. The class C is 192 till 223. Subnet mask is 255.255.255.0. Prefix mask notation is /24 and the host for subnet is to the power 8, means it would come total 256 IP address. Class D. Class D would start from 224, it will go till 239. Subnet mask is not there. This is the /1 and total will get the 32 IP address. Class E 240 till 255 /1 and total 32 IP address. Now, the class A IP address, right? They start from 1 to 126. The subnet notation is 255.0.0 and prefix mask is /8. Similarly, class B 128 to 191. And if you see very carefully, here 127 is missing. And if you remember into the ping class, when we're discussing the ping protocol, so you have seen that 127.1.1.1. When you ping this guy 127.1.1.1 from your PC, if all the internet, if your laptop is not connected with any NIC card, any internet, in that case also you will get the ping response. So this is basically universal loop back IP address. Universal loop back IP. So this range is reserved, like means 127 series is reserved. So this is the IP address. So 127 series is reserved for the testing purpose or as a loopback universal IP address. And rest all you will see they are into the sequence. Now, in each and every class, class A, class B, class C, we have some IP address, and that IP address is basically private IP address. That IP address is basically private IP address. So if I write down the class A, the class A is what? Range is what? 121 to 126. Class B 128 to 191. Class C 192 to 223. So in the class A, we have a range 10.0.0.0 till 10.255.255.255. And in the class B, we have 172.16.0.0 till 172.16.31.255. In the class C, 192.168.0.0 to 192.168.255.255. So this is your private IP address. In each class, class A, class B, class C, not in class D and class E. In class A and class B, class A, class B, and class C, we have a IP address that we use for private communication. Private IP address is that we use for private communication, means our internal communication. So in the class A, we have 10.0.0.0 to 10.255.255.255. And in class C, in class B, 172.16.0.0, 172.16.31. This is the point to remember. Remember, it is still 31, then 255.255. Sorry, this is wrong. Sorry. 31.255.255. So remember this thing, it's still 16 to 31. And then class C 192.168, 0.02, 192.168, 255.255. So these are these all the private IP address, and rest all public IP address. So the private IP address are 10 series and 172 series till 31, 16 to 31. Before that and after that, those are the public IP. In class C, 192.168.0.0 till 192.168.255.258. This IP address is private IP address. Rest all in the class C are the public IP address. So this class of the IP A, B, C, D, whatever, this is not going to impact your day-to-day activity. It's just a identification and categorization of the organization. What does it mean? If I have the big organization like HP, Google, Cisco, if you understand that if if HP use this IP address, in that IP address, in this particular range, you will get total 256 IP address. To the power 8, it would become 256. But HP, Google, or Cisco, these are very big organizations. They need the IP address in the lakhs, not just a 256. So they have to go with this IP address. Class A private IP address means 10.0.0.0 till 10.255.255.255. To fulfill the organization IP requirement, this categorization is there. And it doesn't mean that if I have the small organization, I cannot use the 10 series. I can use the 10 series. If I am the small organization having 250 user or 200 user, it doesn't mean that you have to go with the class C. It's not defined anywhere. It's up to you. It's up to the design part that whether you want to go with the 10 series or whether you want to go with the 192 series or 172 series. It depends on the it depends on the organization. You can use any subnet from the small point of view, small organization. But the big organization, they cannot go with the small IP address. If they go, they have to take the different IP address at each branch. But the big organization generally they go with the big pool because they have the requirement of the lakhs of the IP address. And to get the lakhs of the IP address, it's not possible from the class C, class B. They need to take class A because in the class A we have the 16 lakh more and the class B 65,000. In class C we can get 256 IP address per subnet. And this class of the IP address is not going to impact your day-to-day activity. It's just a number that we use, and we have to work as from the network point of view. We don't have to focus on the class of the IP address. Class of the IP address we have to understand from the operation point of view. Okay, this is the class A IP address. That is for your understanding purpose. You are not going to say that I am working on the class A IP address. If we have the class A IP address, let's suppose 10 and 192.168. Class C IP address. This is class A IP address. It doesn't mean that if you have the class A IP address, you will get the internet, and if you have the class C IP address, you will not get the internet. It doesn't mean internet is not going to check whether you are the class A or class B. IP address is just identity to the system. It's the identity of your edge device. It doesn't mean that if you have the class A or class B, class C, a class A IP address will get the internet access because they have the higher priority or they have the lakhs of the IP address. No, it doesn't mean like that. It's just a network identity of your system that we are assigning that IP address to the system over the IP network to have a communication with different, because this all we are discussing under the IP. This is the time. This is the IP network, IP era, right? So IP is just a number that assigned to system, right? So this is your class of the IP address: class A, class B, class C, and class D. In each class A and class B, class C, we have some IP address reserved for private communication. So let's move next. So the class A IP address is 1.2.126 and 255.0.0.0 and /8. Class B 128 to 191 255.255.0.0/16. Class C 192 till 223 255.255.0.0/24. This is the prefix notation, and this is the CIDR. Sorry, subnet. Prefix and CIDR. This is the subnet or net mask. Now let's write some IP address. Let's write IP address, some IP address. Let's write the IP address like 130.20.20.0/24. From this IP address, can you tell me the first is network address, network bits. Second is host bit. Third is network address. Fourth is host address. Fifth is class of IP address. Sixth, subnet mask. Right? So let's understand one by one. So if you have this IP address, okay. So if you see this thing, right? If you see this thing, so this tells the number of the bits into the network side. So 24 means 24 bits into the network side, and rest all will go into the host side. So if we have 24 bits into network side, then total bits in the IPv4 address, IPv4, we have 32 bits. If 24 bits into the network side, then host side will get the 8 bits. And third is network address. So to write down the network address, what we have to do, we have to make host bit as a 0. So we'll make a host bit as a 0. And host address cannot be written without network address. So we have to write down the network address, then host address and /24. Class of the IP address, right? It comes under 128 till 191. That means it's a class B IP address. And from where we are identifying this is the class A or class B, the first octet. If you remember, the IP address is 4 octet, 4 byte 32-bit decimal number. So this is the first octet, this is the second octet, this is third, and this is fourth octet. So the from first octet we can identify it's a class A or class B. And if you see very carefully, for the class B, this is the class B IP address. For class B, what is the net mask? But what we have here, what we have here, IP address is class B, but the net mask or prefix mask is from the class C. Don't you think it's wrong? It's not wrong actually. The IP address is further divided into two parts: class full IP address and the class less IP address. So class full and class less IP address. IPv4 address. Class full and classless. IP address with default mask. IP address not with default. For class A, what is the default mask? /8, class B /16, class C /24. If we have the IP address with the default mask, that means it's a class full IP address. An IP address without default mask, it's a class less IP address. So if you see here, class B IP address. So technically, class B with the default mask. For class B, the default mask is /16, but what we have here /24. It means this IP address doesn't have the default mask. Then it's a class less IP address. Class full IP address with a default mask, classless IP address not with the default mask. So in such case, this IP address is having different notation, different term that we use to call them. So if you come here, if you see any IP address, let's suppose I have the IP address. Let's take the same IP address, no problem. 130.20.20.20/24. This tells the class of the IP address. Class of the IP address is class B. This tells the number of the bits into the network side. 24, host bit is 8. So the IP address default is called subnetting. If this is the class B IP address, so for the class B IP address, the subnet mask is /16. But what we have here /24. So this is the class B IP address not with the default mask. It means class of the IP address not with the default mask. It doesn't have the default mask. It's a, first of all, it's a classless IP address and subnet mask of 24 bits. So if you see this thing, it's a class B IP address with subnet mask of 24 bits, because this is 24 bits, right? So this is the subnet, means IP address not with the default mask, right? And that is also if greater. If you see this IP address once again, class B mask is what? /24. So for the class B, technically the mask should be /16. But it's not 16, it's a greater than 16. So this, if we have the class IP address greater than the default mask, that comes under the subnetting. IP address which has the greater subnet mask than subnet mask compared to default mask is called subnetting or subnet. So class A technically should have /16, but what we are getting /24. It's a greater than default mask. Compared to, if you compare with the default mask, it's greater than, this is subnetting or subnet. Another thing, let's take the same IP address 130.20.20.20/8. What is this? Class B IP address. For class B IP address, it should have /16. But what we have here? /8. The /8 is class A default mask. So IP address with the less subnet mask, with the less mask compared to the default mask, it's called as a supernetting. So this is the supernetting. If the mask is less than given mask, then it is called supernet. If mask is less than the given mask, what is the given mask here? /16, but what we have /8. That means it's a supernet. If mask is greater than given mask, if mask is greater than given mask, if mask is given than greater mask, if mask is given than if mask is greater than given mask, what is the given mask? /16, greater subnet. If mask is less than given mask is called supernetting. Given mask is what? /16. What we have /8. This is the supernet. Clear? If that is clear, then let's move further. Let's suppose our organization is there, ABC organization. This ABC organization having branch offices in different countries or different locations. If any organization, if a organization ABC having branch offices in India, let's suppose UK, US and Australia, if they are connected with each other, then they must definitely connect with WAN and MAN technology, wide area network and metropolitan area network. We cannot use the LAN. And from the organization point of view, if we get one IP address, because this is the IP networking, so we need to take the IP address. We need to take IP address like, let's suppose 16.0.0.0/8. If I have this IP address, so I need to assign this IP address to my branch offices, right? I need to assign this IP address here because this is my LAN. And over the WAN also I need to assign the IP address. I need to assign here, 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 here. And India, again I have to assign the IP address in my LAN. So what I can do, I can assign the IP address from here. Let's suppose I'm assigning the IP address 16.0.0.1/8, 16.0.0.2/8, 16.0.0.3/8, 16.0.0.4/8, 16.0.0.5/8, 16.0.0.6/8. Here dot 7/8 dot 8/8 dot 9/8. This is what I can do. If a organization, if if any organization is very big organization that has the multiple branch offices spread all over the world, or geographically they are separated and they want to have a connectivity, so they must be connected over the WAN and MAN technology. Over the WAN and WAN technology, if you want to connect, we have to use the IP address. The IP address that we need to have the connectivity from India to UK, India to US, and India to Australia. In the same way, we also have to have the IP address at the LAN, because here my PCs are there. My PCs also need the IP address. We also need to assign the IP address. If they are geographically connected with each other, then we need to have the IP address, and that must be connected over the MAN and WAN technology. But this design is completely wrong. From the design point of view, this design is completely wrong. So I am saying from the design point of view, this is completely wrong. Then what is the design rule? Design first, directly connected interfaces must be in same subnet. Second rule, no two ports, no two ports of router can be in same subnet. So from the design point of view, first rule is directly connected network interface must be in same subnet. If I consider these things, let's suppose, so this is /8, this is also /8. That means design from the rule point of view, the first rule is fulfilled. Second rule, no two ports of router can be in same subnet. From this router point of view, this is in same subnet, this is also in same subnet, this is also in same subnet. Because /8/8/8 and has the same IP address. So from the design rule, from the second design rule, this design is incorrect. Then question will come, then how would we design this network? If you want to have a requirement where a corporate organization having multiple branch offices in India itself, small branch offices, or multiple branch offices spread all over world, and geographically they are separated, and if they want to have a communication, then how would they communicate with each other? So if you consider those things, so if they want to connect, they must be connected over the WAN and MAN technology. And if you want to go for the MAN and WAN technology, we have to consider the design rule. From the design rule, there are two rules into the design. The first is directly connected interface must be in same subnet, and no two ports of router can be in same subnet. So from design rule, the first is matching, but second is not matching. That means this design is not possible. Then what is the solution? Solution is subnetting. Then we need to understand the subnetting. In your mind, a question will come, sir, why can't we use switch instead of router? If I have the switch, I can put all the subnet into the same, because if you see, if you remember very carefully, router routes between the subnet and switches within the subnet. It's a single subnet. Instead of having a router, I can put the switch. In that case, communication will happen, right? So instead of having a router, we can go for the switch.